Introduction to Rational Expressions, Part 1 of 2. After watching this video, you should be able to answer the question, what is 0 divided by any number except 0, and what is any number divided by 0? You should be able to do this without the help of a calculator. You will also be able to define what is meant by rational expressions and state whether an expression is or is not a rational expression. In order to learn how to find the restricted values of a rational expression, you will need to watch part 2 of this video. Pop quiz. What is 0 divided by 1? Pause this video, write down or say your answer out loud, and then unpause the video. Likewise, what is 1 over 0? Again, pause the video, write down or say your answer, and then unpause the video to see if you are correct. 0 divided by 1 is 0. In fact, 0 divided by any number except 0 is always 0. 0 divided by 0, however, is undefined. Likewise, any number, including 0, divided by 0 is undefined. In general, again, any number divided by 0, including 0 itself, is undefined. Make sure you know this and memorize it. You might take a moment to type this into your calculator. Type in 0 over 0 or 1 over 0. Your calculator may say something like error. This is calculator speak for undefined. On a homework assignment or a test or a quiz, if you write error, you will not get full credit. You need to say undefined. That is the mathematically correct term for what we mean. Well, why do we care about this? Why is it so important to talk about undefined values? Well, the reason is because we're talking about rational expressions. And whenever you work with a rational expression, you might be dividing by an algebraic expression. In other words, x, or whatever variable you're using, might be in the denominator. And when that happens, you have to restrict the domain, right, or the set of all x values of the function, so that your function is never undefined. So again, you need to remember that dividing by 0 causes an expression to be undefined. What is a rational expression? So we've been using this term, but we haven't defined it yet. The word rational comes from the word ratio, which is a fancy word for fraction. So we can expect rational expressions to be ratios or fractions. Unlike the fractions you learned about back in elementary school, however, rational expressions may contain variables, not just numbers, in the denominator. A rational expression is a quotient meaning division, of polynomials. Examples of rational expressions include the following. You might take a moment, pause the video, and write these down so you have an idea of all the different types of expressions that qualify as rational expressions. Let's take a minute to look at the last one, 3 over 2. You might be thinking, well, 3 over 2, well, 3 and 2 are both just numbers. There's no variables there. And that's true. But technically, 3 and 2 are also polynomials. You could think about it as 3 times x to the 0 power, or 2 times x to the 0 power. Remember, anything to the 0 power other than 0 is 1. Okay? So again, a rational expression usually will have a variable somewhere in it, but technically, fractions with just numbers also fit the description or the definition of a rational expression. Because again, technically, constants are still polynomials. So let's take a minute and think about the graph of these two functions. On the left, we have just a simple linear function y equals x. It's a very boring thing. It's a straight line. On the right-hand side, we have a much more interesting looking graph, which is 1 over x. So why are these graphs so different? Well, if we think about the left-hand graph, we can see that x can be any number, right? X could be, negative 500, it could be 0, it could be positive 750. It doesn't matter. It's defined for all values of x. So sometimes this is a bit silly. I think about babysitting, right? So imagine if you're babysitting a little baby that is just learning to crawl, right? You're going to have to give that baby much more attention because, or give it more restrictions, right? Because it doesn't know any better, and it doesn't know, not to, put something in its mouth that it shouldn't or stuff like that. Then imagine you're also babysitting a 12-year-old. Well, the 12-year-old, there might be other issues and stuff. Maybe they're, going through some emotional hormonal angst, but generally speaking, they're probably going to stay alive without your help, right? So the amount of restrictions you have to place on a little baby versus, a teen or a tween are very different. So it's the same thing with this graph, right? Y equals x. We do not need to restrict x We don't need to tell x that it can't equal certain values because why? Because it's never going to try to divide by 0, right? Just like an older person is not, older child isn't going to try to, I don't know, put something poisonous in its mouth, right? Probably not going to happen. So on the right-hand side, you can see we have 1 over x. So at some point, if we let x be equal to 0, we have a problem. We're dividing by 0. We can't let that happen. How do I know that I can't let that happen? Well, it's really interesting because if you look at it graphically, right, we can see that the graph does something really weird at 0, doesn't it? As we approach 0 from the left-hand side, we can see that we're approaching negative infinity. We never get there, right, because you can't really get to infinity. And at 0 itself, look at this, the function is undefined. It does not exist at x equals 0. And then you can see as we approach this function from the right-hand side, we can see that we're approaching positive infinity. So if you're using our metaphor, this guy, he's more like the little toddler or the little baby, right? We have to restrict him because he's going to try to divide by 0, and we can't let him do that. Okay, over here, this is more like your older kid, where we don't have to restrict anything, right? Because this function, y equals x could be 0. That's fine, right? You just have 0, 0. It's never going to try to divide by 0, so we don't have to restrict it as much, okay? So let's keep going. Excluded values of rational functions. In general, the denominator of a rational expression cannot be equal to 0. I feel like I've said this a million times, but that's kind of what we're getting at here. Values that cause us to divide by 0 can be called excluded values or restricted values, or when we get into functions, which we'll do later in this class, you might call them domain restrictions. Remember, domain refers to the set of x values or your independent variable. Okay, to find the excluded or restricted values of a rational expression, again, we say set the denominator not equal to 0, because we're saying, hey, this isn't what we want it to be. This is what it can never be. We can never let it be 0. And then we just solve. And then that's how we find our excluded or restricted values. Okay, and any value that causes the denominator to equal 0 is an excluded or a restricted value. So now that you've watched this video, you should be able to answer the question, what is 0 divided by any number except 0? And what is any number divided by 0? And you should be able to do this without a calculator. You should be able to define the term rational expression and state whether a given expression is or is not a rational expression. Remember, technically, numbers are considered polynomials, right? So something like 2/3 would still be considered a rational expression, even though we all know that you're never going to have to restrict the value of the denominator because it's just a constant. So the next step is to learn how to find the restricted or excluded values of rational expression. So please take a minute and watch part 2 of this video.